Our video today is going to be talking about exponential growth and exponential decay situations that we would see in real life. Exponential growth and exponential decay we see all the time in real life, whether that's talking about credit card interest or bank accounts. We see it a lot. So I'm going to do a couple examples here. The first one that we're going to do is about Billy. Billy has a $2,500 painting that increases in value by 5% each year. How much will it be worth after 10 years? Okay, so in order to do a problem like this, we need to make sure that we know a couple of things. First of all, our equation that we need to use is y equals a times the quantity 1 plus r to the t. So a is our starting amount, so what we start with. R is our rate. It must be written in a decimal in order to plug it in. And t is our time. Knowing all of those things, we can plug in what we know. So I know my starting amount to this painting is $2,500. I know the rate at which it increases every year is 5%. So 5%, it says it needs to be written as a decimal. So I'm going to move my decimal over 2 to get my percent to a decimal, so 0.05, and then my time is t, so that would be 10 years. So I'm going to really quickly reduce what's in or simplify what's in the parentheses there, and now I'm going to take my calculator, I'm going to plug it in. So I have 2,500 times 1.05 to the 10th. And there's my answer. So y equals $4,072.24. So because we are talking about money, we're rounding it to the hundredth there. That 6 is higher than 5, so we round up the 3 to a 4. So that's exponential growth. We also have exponential decay problems. So let's read an exponential decay problem. A compound has a half-life of 2 minutes. If a 300-gram sample sits for 10 minutes, how much is left? Okay, so half-life is going to follow pretty much the same formula, except instead of a plus, it's going to be a minus. Now, half-life is special because half-life means half of that compound decays every period of time. So if it's half of it, half is 50%, right? So if I'm trying to find 50% and write it as a decimal, we're going to go over 2, so it's going to be 0.5. So y equals, what do I start with? 300. 1 minus 0.5 to the, okay, now here's what's tricky. The t stands for time, right? But remember our half-life is measured in a certain unit as well. So my half-life is 2 minutes. And if I have a total time of 10 minutes, how many half-lives are in 10 minutes? 5, right? 2, 4, 6, 8, 10, 1, 2, 3, 4, 5. So that is what I'm going to use for time. So instead of using 10, I'm going to use 5 because there are 5 half-lives that happen in that period of time. Okay? So I'm going to subtract 1 minus 0.5, which is just 0.5 there. And now I'm going to plug it into my calculator. So I have 300 parentheses 0.5 to the 5th. There's my answer, 9.375. And then I always put a unit on the end there, so grams. So like I mentioned before, we have a lot of real-world examples of exponential growth and decay. Hopefully this video cleared up at least 2 of those for you.